Hello. This is for some Calculus 2 students. Before the break, we were working on improper integrals, and I got a couple up here on the board I'd like to work out and see what happens. The reason this is let's start with this one. The reason this is an improper integral is because of that infinite bound. Sometimes the zero causes problems. I'll get that in a minute, but not here on this problem. This function is defined at 0. But that infinite bound makes it an improper integral. And so the first thing we do is we make it proper with this little funny technique. We take the limit as a goes to infinity, and we replace that from 0 to a. I can use a or b or c. So there you go, replacing the infinity with the letter a, and then taking the limit as a goes to infinity of this integral. And then our job is to do the integral, evaluate it from 0 to a, and then do the limit and see what kind of an answer we get. So here we go. In order to do this integral, you know there's a little u substitution involved. I think you know the answer is -1/2 e to the negative 2x. So I skipped over the u substitution. I'm going to evaluate it from 0 to a. That means I plug in an a, I get -1/2 e to the negative 2a minus -1/2 e to the 0. You plug in the a, you plug in the 0. There's the answer, but I am trying to take the limit as a goes to infinity. Well, let's see here. Maybe you know that if I if I take the limit as a goes to infinity, I have e to the negative infinity here, and e to the negative infinity goes to 0. This term goes to 0. I'm left with this. This e to the 0, of course, is a 1, so I'm left with this answer, +1/2. That's my answer, +1/2. And when I get an answer like that, a numeric answer, what I say is that this integral converges. This integral converges. It's an improper integral and it converges. Just for fun, it's kind of fun to think about what this looks like. This graph is e to the negative 2x, which is a decreasing exponential function. Dives real close here to the x-axis, never crosses, never touches. Crosses here at 1, actually. And we just found the area under the curve from 0 to infinity. The area under the curve from 0 to infinity, this tight little bit of area, even though it feels like an unbounded area, an infinite area, the area is not infinite, the area is 1/2. The integral converges. Let's try this one. This one is another improper integral. This one is improper because of the 0. I have an undefined, this function that I'm integrating is undefined at 0, and I'm trying to use 0 as a bound. That makes it improper. So I make it proper by taking the limit as a approaches 0 from the right, and then I do this integral from a to 4. I am on the right side of 0 because I am working from 0 to 4, and therefore I'm on the right side of 0 as I integrate from 0 to 4. I'm on the right side of 0. All right, so now I have to integrate this. I'm going to move it up and call it x to the negative 3/2, and then of course we'll do a power rule on this problem. Add 1 to the power, that's x to the negative 1/2. Right. Divide by that -1/2. I like to say multiply by -2. I try to evaluate this from a to 4. Let's see. That's actually -2 over the square root of 4 minus -2 over the square root of a. Interesting. That's the answer. I integrate. I evaluate. And now I take the limit as a goes to 0 from the right. Now this is a 2 over 2, of course. That's actually a -1 minus a negative plus 2 over the square root of 0 as a approaches 0 from the right. Well, let's see. The square root is 0. A is really approaching 0 from the right. It's really a teeny number. It's a very teeny number. You take the square root of it, it's a very teeny number. You divide it into 2, it goes in there an infinite number of times. This is actually -1 plus infinity. This is infinity as a approaches 0 from the right. So what's -1 plus infinity? I think we call that infinity, and therefore you can say that this integral diverges. You say the integral diverges because we had an infinite answer. Just to check out the picture on this one, this graph, this 1 over x to the 3/2, we could plot some points, but it looks like one of these. We do a lot of these graphs that look like this. But we're integrating from 0 to 4, so we're going from 0, this point of discontinuity, this undefined place, all over here to 4. And we just discovered that that area is not tight enough to converge. It does not converge to a number like this tight little area. This area is infinite, and therefore the integral diverges. So thank you. Those are a nice couple improper integrals.